Welcome back, everybody. Mr. Renneker here. Today we are going to get started on lesson 6.1 about relations and functions. And I'm going to go ahead and right out of the gate encourage you guys to pause the video if you don't already have pencil and paper ready to take some notes and work on examples yourselves. As this is our first remote learning lesson on a brand new topic, it's going to be important that just like when we were in class, that you guys take notes and have your own examples to refer to as you go ahead and go through your own practice. So in this lesson, we're going to focus on two main ideas. We're going to represent a relation, which is a new idea, as ordered pairs or a mapping diagram. And then we'll be determining whether a relation, oops, almost got ahead of myself there, whether a relation is something called a function. So a couple new terms that we're going to have to define and work with, but those are going to be our main goals by the time we're done with this lesson. Let's go ahead and get into it. We'll start off with this key idea about relations and mapping diagrams. So here's our first word that we saw on our previous slide. A relation is a situation that pairs an input with an output. So if you guys look over here on the right-hand side, you see a set of input-output tables. And what we're going to try and do in a few moments is connect inputs and outputs to other ideas that we already understand. Next, a relation can be represented by ordered pairs, which we see here, or the mapping diagram, which is this setup we already previewed on the right. Now we'll start making a connection between the two items here, the ordered pairs and the mapping diagram. So we want to see how do the values in the ordered pairs connect to the mapping diagram and vice versa. They color coded them to help you with it. For example, you'll see that all the inputs here, they're in blue, all the outputs in red, and so on. But then we would look at the ordered pairs, we see that these first values right here are all in blue and the second ones are all in red. And they did excuse me, they did that to help you make a connection and to something important you're going to want to have in your notes. We notice that the first values in the ordered pairs, those things are all blue, and we know that that first value is known as our x value. And then the second value, which is all red, just like our outputs over here, those are labeled, or those are all of our y values. So you'd want to make sure that you guys can see and make the connection to the fact that anytime, and I mean any time now, that we discuss inputs, they're really referring to the x values. And if they talk about outputs, they're talking about y values. Now, that's going to be important because in the last, let's see, 2 chapters now, we have predominantly worked with x values, especially in regards to linear situations, linear equations, graphs, and so on. Those same ideas are going to be very heavily used here now that we're starting chapter 6. So what you're going to be asked to do with this information is you're going to be asked to either take a mapping diagram and write it as ordered pairs or vice versa. So we're going to go ahead and take a look at our first example. Okay, in example 1 here, again, we're going to be listing ordered pairs of a relation. So when we say relation, which is just made of inputs and outputs, we can kind of think about it like a relationship. In other words, how are these two values interacting with each other? So we're going to list ordered pairs, meaning an x and y pair shown in this mapping diagram. So again, a relation, that is just one input with whatever output happens as a result of it. So in part A, the first one we would have is the input of 1 with an output of 3. Remember from our previous slide that inputs are always x values, where outputs are going to be the y's, which means that the first ordered pair we'd have is just 1, 3. You'd continue down the mapping diagram in the same way. The next one would be 2, 6. We have 3, 9, and last but not least, 4, 12. So that's the first skill that you guys are going to focus on. And again, as long as you guys are pretty clear on the fact that inputs are x values, outputs are y values, that helps you create ordered pairs, which we have a lot of experience with pretty quickly. Now, part B, you notice that the input-output scenario, your relation is a little bit different. You got some extra arrows going places. So I want to make sure that you guys understand to follow the arrows as you write your ordered pairs. I'm going to always start in the input table here to get us going. So the first ordered pair I see is 0, and following the arrow, 0. There's 1. Now the next one, you see that the number 2, let me get this out of the way, connects to actually two different numbers, so we're just going to take them one at a time. We do have the ordered pair 2, 1, but we also would have the ordered pair 2, -2. Now, in general, just creating the ordered pairs, that hopefully doesn't seem overly complicated, but this specific situation is going to result in something else later on. And last but not least, then we have the ordered pair for -3. So that is one of the skills you guys will be working on, listing ordered pairs from a mapping diagram. Again, a mapping diagram, that's simply what you're seeing here, an input and output table together. If you'd like to test this out on your own, here are two example problems that you can try. Just like we did a moment ago, your job is to list ordered pairs from the mapping diagrams that you have here. If you'd like to test yourself to make sure you fully understand, go ahead and pause the video now and the answers will appear in just a few seconds. So here are the solutions that you guys should have come up with, all the ordered pairs. I'd encourage you to go ahead and pause the video here in just a moment so you can double check your own, and then we're going to go ahead and jump into example 2. In example 2, our job is going to be to determine whether relations are functions. So we're going to need to define what a function is, since you are now familiar with relations. A function. So we have a relation that pairs each input with exactly one output is a function, and that's how we describe that. So what that means is that when you guys look at input and output tables, we're going to make sure that every input matches with only one output. The opposite is not important. Outputs can be matched with however many inputs, but the opposite cannot be true. So let's take a look at what that might be. So in part A here, we're going to take a look at each input and make sure that it only matches with one output. So we've got -9 here, which matches with only 0. That is an input with one output. So far, so good. -2 with +5 are matched with one output. +5 is matched with +10, matched with one output. And +12 with also +10, but again, each input, so all of these guys, are only matched with one output, and each one fits that category, so we would say yes, this is a function. Now, I'm sure some of us are a little bit confused right over here because the 5 and the 12 both match with the same output. So let's take a look at part B to help clarify why it's okay in part A. So in part B, again, we're going to match inputs with outputs. Starting at the top, -2 only matches with one other number. -1 only matches with another number. But right here at 0, we found that the input 0 matches with both +5 and +6. That is a big no-no in the world of functions. Okay? So if you have an input, basically with arrows going to more than one output, this is not a function. And that's the big difference between A and B. In part A, every input only had one arrow coming away from it. In part B, there was an input that had two arrows coming away from it or had two outputs. That cannot happen for it to be a function. Again, inputs like the 10 over here in part A, that outputs can have as many inputs as they want, but the opposite cannot be true. In our next and final example, we're going to talk about how we can describe mapping diagrams. And what they're asking us to do is consider this mapping diagram over here on the left. It is a function, which is what we're going to talk about first, but you guys should be able to see that because every input only goes to one number. There are no inputs with more than one arrow coming away from them. So part A says determine whether the relation is a function. So you guys are actually going to be asked to put that into words and not just use the picture. But we did that just a moment ago, and it would look something like this. Putting it into words and or a sentence, you would want to explain that in words by saying each input has exactly, and that's a key word here, one output. So the relation is a function. Now that we've proven it's a function, part B says or asks us to describe the pattern of inputs and outputs in the diagram. So what they're asking us to do is look at how are things changing together. So how are the inputs changing each time? How are the outputs changing each time? And since they are changing together, they're in a group together, we're going to try and describe what happens. Of course, we look at the inputs. We say, okay, as we go from 1 to 2 or 2 to 3 or 3 to 4, how are the inputs changing? And we can connect pretty quickly that they are going up by 1. As we look at the outputs, go from 15 to 30 to 45 to 60, and it's not always going to be addition, just as a little side note, but we can see that the pattern here is plus 15 each time. So what I'm going to show you guys here is how can I explain those changes, the changes in the inputs and the outputs together, and it would look something like this. We could say something like, as each input increases by 1, the output increases by 15. Things that could potentially change. Words like increases could also, of course, appear as decreases, and the amounts that they're changing by, those would be things that would change as well. The last thing I have for you are just some example problems you can try on your own. Here they're asking you to determine whether the relation is a function. And so these should simply be yes or no questions. Yes, they are a function. No, no, they're not. If you'd like to try these ones on your own to see if you really understand how to tell if a relation is a function or not, go ahead and pause the video in a couple seconds, and the answers will appear shortly after. And here you go. Number 3 is not a function. We had inputs with more than one arrow or more than one output. Number 4 is a function. Every input only had one arrow going away from it to another output. And that's everything for section 6.1 about relations and functions. The first things that you guys will be exploring here. Again, to start off chapter 6 about functions, we focused on representing a relation. That was you writing them as ordered pairs over here, or in a mapping diagram. Of course, you hopefully notice we use mapping diagrams a lot. And then also determining whether a relation is a function. That's a yes or no question based on that mapping diagram, or they might even sneak in more ordered pairs as well. Good luck with the first lesson on this one. Hopefully you're already using Google Classroom unless you got this link from a friend. But make sure you guys are checking in on that for all the latest updates. Tutorials will typically be on Thursdays. And other than that, guys, good luck, and I will see you next time.